All right, hi folks. I tried to reproduce this video that I saw online by the Action Lab guy, and it's basically the electroscope charging it up and making it works with a ultraviolet type C lamp, which puts out a wavelength of 254 nanometers, as you see here. It's a germicidal lamp, in other words, the one that I put inside this thing here. The reason why I put it in the cardboard is so that it actually shields the light from hitting my eyes and so on, right? Overexposure. So what I'm going to do now is take a rubber rod and some fur, charge it up. Let's make sure it's all charged. Yeah, it's charged up. And I have over here the electroscope, and on top I use a fresh piece of aluminum foil. And what I'm going to do is just charge this thing up so that it has negative charges on it, electrons, as you can see. Oops. Needs a bit more there. Maybe a little more. Let me go ahead and do this again. Saturate this thing with the electrons. The reason why I'm using a piece of aluminum foil folded up like this on top is because the aluminum on top, the disc itself, is anodized and it has a hard time releasing electrons, using this effect. So aluminum foil is a little bit thinner layer of oxidation on the surface, so it should work better. As you can see now, it's stabilized. There's charge on this electroscope. And using the rubber rod and fur, we're able to get negative charges onto the system there, right? So just to demonstrate this photoelectric effect, I have here a lamp that outputs red light. So go ahead and use red light on here. Red light doesn't have enough energy to kick off the electrons, all right? There's this thing called the work function, which is basically a threshold amount of energy that is required for the electrons to be kicked off of the metal. And for aluminum, it's about 4.2 electron volts. That's the value is required. And this does not have enough, right? So let me switch it over to green. The green coming out of this thing also has no effect on kicking off electrons. If I switch it to blue, which is a shorter wavelength, even blue has no effect on this thing. All right, you can see that the charges are not leaving the system there at all. And I also have this thing here, which is a violet laser. And I'll be shining this onto the surface here, like you see there. And it doesn't seem to be doing anything to kick off electrons. Not enough energy in the photons of this laser. So what I'm going to do now is use the UVC lamp, which has a wavelength of 254 nanometers. If you convert this over to electron volts, the photons coming off of this thing is centered around 4.89 electron volts, which is higher than the 4.2 that is needed to kick off electrons from the aluminum. So I'm going to face this down over here, or sideways, turn on the lamp. Oh, I got to plug it in first. There we go. Lamp is on. You can see it glowing. There's the electrons on. The electrons are still on the electroscope there. And I'm going to take the light. You can see the light there. Shine it onto the surface. It looks kind of blue, but there's also ultraviolet coming off this thing at the very high energy. It'll take some time. Right. I'm not touching the aluminum foil at all, but as you can see, it is being depleted of the charges because the electrons are being kicked off of the aluminum foil due to the fact that this lamp here is putting out high energy photons that are hitting it and kicking them off. And so The electrons that have been deposited onto the electroscope are slowly being depleted away, being kicked off by the high energy photons of light, of the ultraviolet, the very short wavelength. And there you go. Photoelectric effect, folks. It actually works. Now, this did not work when it was like this. This is aluminum, but this aluminum here is anodized. It has a hard surface to it due to the fact that it has oxidation. Probably, it has a thick layer of aluminum oxide to help protect it. And so it doesn't work very well in being able to emit or kick off electrons from the surface. You need a fresh piece of aluminum on here to be able to do what it needs to do, all right? Because this has a thinner layer of oxidation of the aluminum oxide on the surface of the aluminum foil. This works a lot better this way. So if you use this on top, you'll be able to run this experiment too using the UVC lamp, okay? And I bought this on Amazon for about 14 bucks, I think it was, all right? This is not a toy though, all right? It is damaging. It is supposed to be a germicidal lamp, so it kills germs, it kills bacteria, and if you expose your hand, it'll probably kill the cells in your hand little by little, so it's not a safe thing to play around with, all right? It can damage, cells. So I don't recommend, waving this around in front of people's faces or anything like that. It's a dangerous lamp, okay? Anyways, this does demonstrate photoelectric effect very well though, all right? And so I just wanted to share this with you. Cheers.